Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to AFSAC's online support program. This is your geography teacher of grade 6, APS 4 Road Middle Wing Boys. Today we will be discussing task for week 7. Starting with Hadith of the day, Hazrat Muhammad sallallahu alaihi wasallam said, "Whoever prayed at night in the month of Ramzan out of sincere faith and hoping for a reward from Allah, then all his previous sins will be forgiven." Students, we have started from our chapter number 2, Natural Spheres. Our this week's objectives are, you will be able to know and learn about the global wind system, planetary winds, seasonal winds, and local winds. Students, these are the tasks for week 7. You have to read the following pages: global wind system, planetary winds, seasonal winds, local winds. You have to study the picture with the title and highlight the important points on the book. Like I told you earlier, you will maintain a small notepad or booklet for preparing a bank of words you find difficult. You have to go through from page number 31 and 32. Student, you also have to do the research and gather more information about the structure of global wind system. Go through the figure 2.9 and do an extensive research on your own to learn about the global winds. You can do the map study, use Oxford School Atlas wherever it is required, and don't forget to go through the interesting facts, map reading diagrams, and graphic organizers. Students, these are your pages from textbook, page number 30, 31 and 32. Don't forget to highlight the important points while reading from your textbook pages. Coming on the topic, what are winds? Have you ever wondered that there is a proper pattern for the movements of the wind? Now here we will discuss step by step all the basics of global wind system. I hope you will understand them easily. What is wind is our basic question. Now wind is moving air and is caused by differences in air pressure within our atmosphere. Now students, we all know that Earth is made up of lands and oceans. Because of it, sun radiation is distributed unevenly. Now we know that warm areas causes air to rise and low pressure is formed, while when air is cold, it causes high pressure. Air under high pressure moves towards areas of low pressure. It causes winds. The greater the difference in the wind pressure, faster the air flows. Student, now look at this figure. We can call this figure as global wind system in a nutshell. Now before going to the explanation of topic, I want you to revise your geography terms. Let's do a recap. This is equator. It divides the earth into northern and southern hemisphere. These 30 degree and 60 degrees are lines of latitude. These are poles of the earth, North Pole and South Pole. These yellow arrows are the winds. Now look at equator. Because of hot temperature at equator, low pressure is formed and air rises. When the air gets cold at 30 degree, it sinks and high pressure is formed. Global wind systems is divided into 3 parts. On a larger scale, they are divided into planetary winds, seasonal winds, and local winds. Planetary winds, these are winds blowing throughout the year from high pressure belts to low pressure belts in the same direction. It includes trade winds, westerlies, and polar easterlies. Trade winds. When the air blows across the surface toward the equator, It is called as trade winds. It moves from northeast in northern hemisphere, while moves from southeast in southern hemisphere. They are called trade winds as sailors observed the wind pattern in tropics and created trade routes while relying on these winds. Christopher Columbus first discovered these winds in 1400s during a sea voyage. The next one are westerlies and polar easterlies. Westerlies are prevailing winds from east to west between 30 degree to 60 degree latitude, while polar easterlies are at poles and they are extremely cold air flows from poles towards the equator through circulation in polar cells. Student, look at this figure. It is figure 2.9 from your books. It consists of Hadley cells, faryal cells, and polar cells. Now we will discuss these in the next slides. Now students, look at the figure at the Hadley cell. It was named after George Hadley. In this cell, air rises up in the atmosphere near equator, returns to the Earth's surface in the subtropic and flows back to the equator. It occurs because sun heats the air near the equator. They are found in 30 degree north and 30 degree south. These are the faryal cells. Now look at the figure. In this cell, air flows from poleward and eastward. It is not driven by the difference in the heat energy. It is found in 60 degree north and 60 degree south. Atmospheric pressure is low here. Now comes the polar cells. Can you see them at the end of the poles? These are extremely cold cells. They extend from 60 degree and 70 degree north and south to the poles. Extremely cold air called as polar easterlies flows from poles to the equator through circulation in polar cells. Planetary winds help to transfer heat from the equator to the poles so that temperature on the Earth can be regulated. Coriolis effect. Coriolis effect is a force by which things like winds or planes get deflected. That is, they appear to move in a curve instead of a straight line. Now if you look at the figure, northeast trade winds in northern hemisphere deflect to the right, while southeast trade winds in the southern hemisphere are deflected to the left. Now students, for better clarity of things and this tricky topic, let's watch a video. I hope you will get a better understanding.
Different parts of the Earth heat up differently, with the equator receiving more radiative heat from the sun than the poles. And the purpose of global circulation is to redistribute this heat. If the Earth did not rotate and was a simple landmass with no oceans, we would have a single circulatory cell in each hemisphere, where hotter air would rise at the equator and flow toward the poles. The air would sink as it cools and then return towards the equator. But the unequal distribution of land and ocean and the speed of the Earth's rotation make this circulation system more complicated, giving us a three-cell pattern which exists in both the northern and southern hemispheres. The largest cells are the Hadley cells. At the equator, the warmer, less dense air rises. It rises to a height of about 18 kilometers and spreads out underneath the tropopause. The tropopause acts as a lid to the lowest part of our atmosphere, which contains all of our weather. The warm air spreads out towards the poles, gradually cooling and sinking as it moves, before descending to the surface and flowing back to the equator. The smallest cells are the polar cells. Cold, dense air descending in the polar regions flows at low levels to about 60 to 70 degrees north or south. As the air leaves the polar regions, it starts to warm and rise, returning to the poles at high levels. Between the Hadley and polar cells are the faryal cells. Unlike the other cells, the faryal cells are not driven by temperature. These cells flow in the opposite direction to the Hadley and polar cells, acting like a gear. These circulating cells not only transport heat from the equator to the poles, but also result in semi-permanent areas of high and low pressure due to the rising and descending parts of the circulation cells, giving us our climatic zones. Where air is rising, an area of low pressure is created, so these areas see much more rainfall. This is why the largest areas of rainforest are found near the equator, and why the United Kingdom has a relatively wet climate. Where air is descending, an area of high pressure forms, giving largely clear skies and little rainfall, which leads to the desert regions. But not all deserts are hot. Antarctica sits under the descending branch of the polar cell and is also classed as a desert. With more precipitation falling in the Sahara, Antarctica is the largest and driest desert overall.
Students, our next topics are seasonal winds. Seasonal winds are movements of air that are repeatedly and predictably driven by changes in the large-scale weather patterns. Now, monsoon winds are a very good example of seasonal winds, which bring wet and dry seasons to the tropical regions. Monsoon winds in Pakistan. We will discuss monsoon winds from June to August. During summers from June to August, sun rays heat up land more quickly than water. Now land gets warmer than oceans. A low pressure area forms over land, while a high pressure area forms over the ocean. The southwest monsoon occurs over Pakistan as wind blows from Indian Ocean to continental area of Pakistan, bringing a large amount of rain. Monsoon winds in Pakistan during December to February. The converse happens during winter from December to February. Since land is cooler than oceans, a high pressure is formed over land, while a low pressure area is over the oceans. Northeast monsoon occurs over Pakistan as wind blows from continental Central Asia to Indian Ocean. Since there is little moisture available over Central Asia, Pakistan experiences dry weather during this period. Now we come to the last type, that is local winds. Local winds are movement of air that occur over a small area ranging from tens to few hundreds of kilometers. Common examples of local winds are land breeze and sea breeze. Land breeze. During the night, land cools down more quickly than the sea. A high pressure is formed over the land, while a low pressure is formed over the sea. Due to this pressure difference, wind blows from land to the sea, resulting in land breeze. This is the sea breeze. Now during the day, land heats up more quickly than the sea. A low pressure is formed over the land and high pressure is formed over the sea. Due to this difference in the pressure, wind blows from sea to land. This is known as sea breeze. Now students, this is all for week 7. If you have any questions regarding the topic, feel free to discuss. Take care and Allah Hafiz.